Okay, so for the first problem, we're going to start by just drawing a diagram here. So we have two players. The first one has a mass of 80 kilograms and is going 45 degrees east of north, and this is their velocity. And the second player is going 60 degrees west of north. This is their speed. And we're trying to find the mass of the second person. So we'll have our mass m here. And we know that the direction is east of north. So we're going to start in a north direction and then go east from there. So it's going to be in this direction. And we know that the angle is with respect to here. I could draw that better. So this is our angle, which we're going to call theta, which we know is 45 degrees from the original problem, and this holds our velocity. Here is our second mass, which I'm going to denote with a lowercase m. It says that they're going west of north, so we start in the north direction and go west from there. And we know that they're going at this second angle, which I'm just going to call phi, which we know is 60 degrees. After the impact, it says that they moved together directly north, so this is our before picture. And this is our after picture. Where they're both going directly north at just some final velocity. We don't know what it is yet. So, to start solving this problem, we want to use conservation of momentum. Since they're moving at angles, it's helpful to split it up into the x and y direction. So, we know that in the x direction, we need the p initial, the initial momentum, to equal the final momentum. So when we look at our initial momentum here, we can draw triangles of the motion really quickly. So this is our velocity and this is our angle theta, and we're looking for the x. So we're looking for this right here. So we know that the mass is just going to be m, and our velocity is going to be this v sine theta. And we are subtracting it from the same thing on the opposite side, which is going to be v2 sine phi. The reason that we're subtracting it is because I'm setting this to be our positive and this to be our negative. This one is moving to the right, so positively, whereas this mass is moving to the left, so negatively. So they're in opposite directions, so they're subtracting. And in our final image here, there is no motion in the x direction since they're only moving in the y direction, they're only moving up in the y direction. So we can set this final equal to 0. And this is all we need to get our first solution because we don't need to look at the y right now since there's only one unknown in this equation. So we can rearrange our equation and substitute everything in. We're trying to solve for our little m. So we'll get that m v1 sine theta is equal to m v2 sine phi, and we can just divide everything over, so we can get that v2 is equal to m v1 sine theta over little m sine phi, And you can just sub in your values here and solve. Oh, sorry, I just realized we're solving for our m, our little m, not our v. So this should be like this. And you can just solve this numerically. For the second part of the, and for this you should get 54.4 kilograms. For the second part, now we're looking for this v final here. So let's set up our y equations and see if that gives us any information. So the initial is basically going to be the same, except now we're looking for this side, which is going to be associated with cosine instead of sine. So we're going to get big M v1 cosine theta plus little m v2 cosine phi, and this is going to be equal to our final. This is one system, so we can add our two masses. So we can have big M and little m, and our v final, which is what we're solving for. And now we only have this one unknown since we just solved for the mass. So we're going to get that the v final is equal to this long expression. All over the sum of the two masses. And once you plug all your values in here, you should get this. The reason that we're adding here instead of subtracting like we did here is because unlike in the x direction, these two are moving in the same direction in the y. They're both going north. If this one was moving down and started above this other player, then the signs would be switched. And that is everything for question 1.